So in a previous video you probably saw me use this soldering iron with these adapter tips here to press in these inserts. Now I know these are the wrong type for 3D printing, but this is what I have at the moment. And I was thinking there's got to be a better way of making sure, one, this goes in nice and straight, and two, you don't press it too far so you mess it up like I did on my first one. Now it turns out, a little bit of internet searching, lots of people have been here before and they've made little devices, so I thought, why don't I have a go? Let's get started. Now I was having a look through my bits and pieces drawer. I've built lots of devices, CNC machines, all sorts of things over the years, and count a few bits that might be useful. So I think we've got two of these linear guides. Now, I don't know if it was Mark II or Mark III. I think Mark II CNC machine used these, believe it or not. These little 15mm linear slides for the Z-axis. That might come in useful. Offcuts, got a few of those. And some miscellaneous brackets. What else we got? Box of springs. Because what I might do is the style where you bring the whole machine, or the whole soldering iron down to a certain depth, and then it's kind of spring loaded to actually do the pushing in. Yeah, that might be useful. So like a two-stage system. What else we got? That might be useful. Needs a bit of a clean up, but maybe that'll make a nice little base. Maybe even have some drawers underneath to put all the heat inserts. You so pull the drawer out, you've got all the different sizes, so it all stays together. Don't know, maybe. I think there's enough bits there. Should be able to throw something together. Right, let's get into CAD and see what I can come up with. Okay, so let's jump over to the CAD, and here you can see the basic layout. So it's making good use of all the parts I've already got, so I kind of based my design around that, and also having a look around the internet and seeing what other people have done, and then just pulling the best ideas. Then I've got a linear rail that allows the whole assembly to move up and down, move the soldering iron into position. Then I've got a lock screw at the back, and it's joined onto the arm, and there's a little pin in there with a spring, and that keeps them separated until you're ready to solder. And then you lift the arm up. So the idea is you use the lock screw to move the whole assembly into the final position. So this is as low as it will go once the insert is driven home. And then the arm is held on that pin via that spring, and you lift that up, put the insert in, and then it's the spring that applies the preload down to push the insert in, obviously once the soldering iron is on, nice and hot. So hopefully this design will work. It does make good use of all the parts I've already got. There's no sense buying anything if we've got rails and bits and pieces. While I was out and about today, that piece of wood I was going to use for the base, it wasn't super flat, it was quite warped and the edges weren't that square. Found this, some kind of chopping board, I don't know what it was, in some kind of second-hand shop, and that's really flat, so I think we'll make use of that for the base, and then maybe mount it in the corner. That gives maximum reach. To be honest, if I go at the edge just here and have it normal there, that'll also be pretty good, because there's plenty of reach on that as well. Anyway, we'll put this to one side, so we'll use that a bit later. Let's have a look at the rest of the parts. Right, I thought rather than print that really long bracket that clips into here, which is going to take 1 hour 50, something like that, I thought I'll make it just a little test piece. So I cut that CAD down so it's just the grip that goes around here, because this is actually tapered, and I wanted to make sure it was a nice snap fit into there. So I've measured that diameter, went up 50mm, measured that diameter, and then I made a short part, put that through the 3D printer, and that printed up okay. So you can see that's the base, and that's the bit that goes around there, and then the rest of the handle sort of over here. And which way around did it go? I think the printed slice was at the bottom, so it would have gone that way. And what I found was it was a pretty good fit just at the bottom there. I don't know if you can see, but this top end, there was quite a lot of play. Probably not easy to see on camera, but yeah, there was a bit of a gap at the top here. It wasn't going to be like a nice snap fit, so it's quite loose already. I haven't come all the way around yet. So I measured it again. I realised that actually this was only 40mm high, and I've measured to 50. Originally I was going to do a big 50mm bracket, so that wasn't helping. So I put the new CAD in and printed out the new one. I'm quite new to 3D printing. I only got my printer a few weeks ago, but already I've printed quite a few things and I'm learning fast. I did have a few things come undone, so I discovered that brim feature. So I'm now running with 12mm brim around everything, whether it's thin, small, whatever. Yeah, there's hardly any plastic used, and it's no issue to remove it after. And then also, on the advice of many others, bump the bed temperature from 55 to 60. I'm only printing PLA, but as you can see, that's printing nicely, and I've probably printed 10 things since, bits and pieces, brackets, all sorts of things, and they've all been fine. So the brim and the higher temperature seems to work. And then once we're finished, here is the part, and you can see that was the side it was printed. See all the texture, the layers in that's really nice, isn't it? Okay, it's just, I think when it's done the top layer from the infill gone to the top, it's just got a little line there, but really nice smooth walls. Obviously you can see this is the black PLA, and the idea is that the soldering iron should clip in there. It's a little bit flexible around that cutout there, and then these are just lightning holes, or stop me filling in all that material. Didn't really need it. Plenty of bending strength, and it's really, really stiff. So pleased with that. We'll come to that in a minute. And then I've got these little holes here. Now there were some little supports that came down. I don't know which side they were on, probably this side I think, came down from the bed to allow you to print those holes, because you're printing over an open unsupported surface otherwise. So I just got those last bits to take out, and then that hole there, that was also unsupported there, so it's got that fill material which I need to work out how to remove. And that should have been a through hole. It looks like it's gone through to there. So again, I'll have a look in a minute. I might just get some tools, some fine tweezers, little screwdrivers, whatever, just to remove this stuff. That looks like it's pretty hard in there. And then the idea is there's an M8 nut will go into there and give me a nice 8mm thread. So we'll clean that up in a minute, but that was the main arm that screws onto there. That allows it to go up and down, and then it screws through those holes there. Alright, so that was the first bit done. I guess we need to see if it actually fits on the soldering iron. So I'll remove this, so I don't need that anymore, so I'll probably just cut that off, and it will go on. That's the bottom, isn't it? So it's tapered, so it should fit through there, hopefully. That's a good start. And then it's got a little temperature display here, and then I think that's on off, and then plus minus on the temperature. So I decided I want to still be able to see that. It should fit over the buttons. Does it? Oh yeah. And then should start to get tight. Oh yeah. Okay. And you can still see the display through there. Now obviously it's going to be pushing down against the spring, so it's always pushing against that collar, so yeah, it should be no problem. I guess it might rotate, but it feels pretty firm. Alright, so that's the first one complete. Pleased with that, really nice. Okay, that looks pretty good. So what we'll do now, try the hole. Oh, that was nice. Wow, cool shape. It is amazing when you think about it that when I CNC things on the CNC machine, I write the cam and you have to tell it this is the tool path, use this tool, use this strategy, whatever. Adaptive, pocket, contour. You need all the feeds and speeds, everything. You need to tell it everything, and then you need to monitor the machine while it's running, just in case it does something odd. Might jam up a tool, break a tool, whatever. This one, the cam, the slicer, whatever. It's amazing. You drop a step file in or an STL. You don't have to tell it very much, really. I mean, you can go with the defaults. Do you want a brim? Yes, no. How thick do you want the walls? Default, or do you want supports? Yes. And there's hundreds of variables that all seem to be set up in the background. And you know, you can leave it printing away as long as it's got the first few layers down. Seems to be okay. So alright, that's cleaned up nicely. Just amazing how quick, yeah, compared to CAM in say Fusion 360, just how quick the slicer version is to create the G-code. Right, here's our M8 nut. Should be a nice gentle fit in there. I wasn't quite sure how tight to make it. I didn't want to break the plastic. Looks okay. Can we get a bolt down there? Oh, I think it's threading into the plastic. Should have been I think it was an 8.1 hole, which normally in metal would easily clear. So maybe it's shrunk back ever so slightly. No matter. Haven't caught the threads yet. If you can see down there, not enough light. Okay, I think we've got it. How tight will that go up? Obviously I'm not going to put the full torque of an M8, but oh yeah, that nips up quite nicely. The reason I did that, by the way, is well, a couple of things. One is that's a pretty strong joint, hopefully, but secondly, the heat set inserts seem to go up to about M5, maybe M6. Yeah, I think I've got a 1/420, which is sort of M6, isn't it? Didn't seem to go any higher than that, at least my quick look around. And I guess the reason is, who's going to put an 8mm thread into plastic, you know, and expect to torque one of these up? Probably not done, so don't seem to be for sale as readily. It was sort of M2 maybe, or M3, 4, 5 and 6 were the common ones. Anyway, I think that's quite a nice solution. All right. Gonna get it started with this. I think what I need to be careful of is using tolerances for holes that I'd normally use for metal work on plastic. I think this is a 3.5mm hole. M3 screw. I think 4mm would have been better. I just had a look down, you can just see they're pretty accurate, but I guess the hole might have contracted ever so slightly. Or maybe what I should do is run a reamer through it first. I don't know if plastic's reamable. We'll see. That seems to be going on now. Okay, I think we're there. Guess actually I could have made them a bit shorter so they just sit on that bit, but yeah, alright. Looking good. Right, so that'll be at the bottom. And we need our stop collar to go on there. Okay, then the next part, 3D print, was the depth stops. That's kind of a bracket that governs the overall position of the soldering iron before you actually then push it into the material. And that's the part that you can slide up and down on the upper linear guide, and then there's a locking screw at the back, so it holds it in that position, and that's your set height, and then you can go from there. So again, no problems printing it. This is black PLA. Again, use the brim and a 60-degree bed temperature. I think this took about an hour and a half. It's a fairly big part, and yeah, again, it all went fine. And here it is. So it was, this side was on the bed, and you can just see I've just started to take the support material away. So these holes are where it will bolt onto the upper carriage, and then that hole there is where the pin goes through with the spring down here, and then the other large piece on top stop it going all the way through. Then at the back here you've got a hole, so that will be where the thumb screw goes through to lock it in place. And then I just made these hollow here, so the idea is this would actually bend enough. It's about 0.3 millimeters away from the extrusion, so I'm hoping there's enough force from the screw to actually pull this in and lock it onto here. Essentially it'll go up like that, little carriage in there, so that's up and down, and then it's almost rubbing against there, and then it will ride in a little nut into there and pull that and kind of squeeze it and hopefully lock that into position. But again, you know, really, I am new to this, but I think I'm being spoiled with that printer. That is really amazing. Amazing. I mean, you just see the odd little line like that, but wow. Very impressed. Nice quality, speed, and now I've got the brim and the temperature sorted out, reliability as well. So again, we've got to clean all those out. Yeah, I might need to get some tools for that, but let's see how we go. So that's our sort of depth stop guide complete. Okay, the depth stop's all cleaned up now. I've opened out the holes, and so we can put it on here. So that's the lower surface. And it goes that way, yeah. Do the holes line up? Yep. I probably can't see down there. Anyway, the black plastic doesn't short that well on the film. I didn't have any screws that were long enough, so I ended up cutting these down. And it's a bit of a pain because they're only M3. Just trying to file the ends till they are. Just looking down there and trying to get that level. Doesn't really move very much, but that looks pretty good there. Okay, don't want to overdo it. Alright. And they line up as well. Alright, looking good. Alright, next we'll try the box section and make sure that fits inside there. Obviously it's way too long at the moment. I need to get the distance, so that's got to be off the base, but for now that looks okay. Right, I was going to make a custom nut plate, but this little M8 nut fits in there pretty well and it doesn't turn. It'd be nice if it was a bit deeper, but that might be okay. So I think what we'll do temporarily, I'll just put this half size nut on there. And then try and get that lined up. Got it? Oh yeah. Right, I think we've got that in. Just nip it up. Well, that works really well. Surprisingly well. Alright, obviously we'll make something a bit better than that, but we're just doing a dry assembly at the moment. I think the next thing to do, we need to make or find some kind of nut plate that will go down there and take these, which look like M3. Let's go and see what we've got. Right, while we were waiting for me to find a bit of material that will go in there, I was also having to play around with this. I think this is going to be temporary. I think I'm going to make up something custom. So it's got, basically it looks like a bolt, but it's turned down a little bit there, and this bolt currently ends about there. And on the original plan, I wanted it to go all the way through, and then I could have another nut on the bottom, like a lock nut. Because once I'd got that screwed into there to get that gap set where I wanted it to be, I could lock it off. Now that's not long enough. I've also had to go on the lathe and just turn this down just to make sure it's nice and smooth. The spring rides over it. And also, I don't know if you can see, just there, I just had to put these washers either end because the spring was trying to kind of sneak inside the gap there. So I need to remake these washers, so custom made, so they're a really nice fit, because at the moment they're a bit of a loose fit, and I think probably there's a bit of a chance that spring might go into the gap there, and that will be annoying at either end. So we'll make something bespoke that's going to suit this, but for now this sort of works, and I'll just try it and see what the preload's like once it's all finished and put together, and then we'll go from there. But just to give you some idea of how it will work. So you can see that's really nice and smooth now. So obviously okay, yeah, it just needs finessing. The basic idea I think is going to work. So obviously the soldering iron will be on this one pointing down, like that, and you'll get this into position so that that's obviously at full depth. That is as far down as you want to go, so that's the position where the insert is fully inserted, and then you would lift this up, drop the insert in, and then wait for this to warm up, or maybe it's already warmed up and you put it to one side, and then when you let go like that, it will push. Soldering iron will get pushed down like that and push the insert in, and it will go all the way until that head hits there, and then you move it out of the way or just bring it back up, because that's gone full depth. So that's the idea. I think the basic plan's going to work, and maybe that's good enough to hold. I don't know, see how we get on. Might just have to make some custom washers so they're a nice fit on there, so the spring can't sneak past. Just worried this could come undone because there's nothing really holding it other than just it's in that nut, that's all. Anyway, bit of progress. Right, I think I found the bit of stock that goes in there. This will be perfect, it's a little offcut. I just need machining down a bit. It's nice and flat, and width wise you can see it's almost ready to go in. It's very, very close. Probably needs 2 or 3 mil taking off. I mean, it needs cleaning up anyway. It needs machining down both sides. The top's flat enough, it's just the sides. And as you can see, it's going to be okay. And then we'll drill and tap this. I think it was M3, wasn't it? About every 40 mil or so. So we'll measure this up, get it on the CNC machine, and just manually bring it down into size. And then we'll drill and tap each of the holes, and that will be our kind of nut strip done. Then I had a look at the thumb screw. Now this is the first time just trying a thread, just seeing what happens if I print one. And you can see once I've taken all the support material away, yeah, there's a kind of thread there. But when I went to just put the nut on it, it did kind of chew the end of it, so yeah, maybe it was not really going to work. Yeah, so just put the nut on there, and if you can see, yeah, it starts to chew the plastic a bit. I don't know, we'll keep going. It was worth experimenting with. I guess I could try running an M8 die down there, see if that cleans up the threads. I think we'll make that in metal. Okay, we're over at the CNC machine. As you can see, I've just got the part clamped down there on the edge of that piece of wood. I'm machining some other parts at the moment. I didn't want to disturb that, so we'll just use that edge piece there. Be good enough. We're only got to bring this down to a nominal size. So we're just sweeping across it now and getting it pretty dialed in. It looks pretty close. It doesn't matter because we're going to machine that side anyway, but I thought I'd get it pretty close so we're not wasting stock, and then we can definitely get the part out of that. So we've machined off this edge, and now I'm just trying to dial it in and pick that up again, so then we can machine this edge pretty parallel to it. I mean, it's not super critical, but yeah, it looks pretty good there. It's bumping around a bit, but I think that'll do. Right, let's machine this edge. Let's see where we're at. $14.6. Yeah, about 14.6. I need to be 13.5, so we'll take 1.1 off. That's where we got to. I need to be really reasonably close because it's just got to fit in that slot. Oh, somewhere there. That'll do. So we're over at the drill press. Now you might have wondered why you didn't see me machine it down to length. I took it off the CNC machine and just thought I'd just check the length, and then I was just going to manually cut it, and it's exactly 310, which is what we needed. So that was a bit of luck. So all we need to do now is put, I think it was 8 M3 holes, so 15mm from each end and then 40mm between centres. So we'll just use a wiggler to pick up off probably that end and then centre it in there, and then we'll put our little pilots in. We've got our M3 tap ready to go. Yeah, and then that should be it. Try and get as accurate as I can. There. There she goes. Right. We're on Y, so we'll half that. Okay. Okay, there's a -2 in X. Okay, we've got a 3mm spotting drill in there, so we'll come over 15. Somewhere there. Now I haven't got the electronics powered to the table, that's a different project. So I'm just going to have to extend the quill a bit. Luckily we're within range. Just put our little centre hole in there. Let's double check. Yes, it was on 0, and then with 15. Check the drawing. Yeah. Okay, here we go. Just peck it just to try and keep it on track. It should be pretty good with a spotting drill. Okay. Right, and then we'll move 40. So that's 55 total. double check that. Yep, that's good. We're on track. Right, we'll keep going like that. We'll just spot all the holes. A bit of WD-40. Move it along 255. Now if I get my maths wrong, I should know, because obviously I need to be somewhere near there, which I am. Tap. I would normally counterbore these, but I guess I'm being lazy. I'll do it after I've tapped it by hand with the cordless drill. All I want to do is just get these started, focus on what I'm doing more than chatting. I'll be able to hold the chuck properly. Here we go. Okay, for those of you who haven't seen the build series, I've custom made a lot of the parts, a lot of the modifications on this drill press. It's got a control system on it, so I've got two buttons, jog, to allow me to tap. So if I jog down, jog that way. I think that cheap Chinese chuck has got some run out in it, which is not ideal if you're tapping a small hole like this. Yeah, I think the next upgrade is going to be a proper quality chuck on this, but anyway. Okay, come out again and go to the next one. Yep. And 295. Okay, I've got it inserted there and I've got it lined up, hopefully. See if these fixings are too long, too short. I'm not going to get it all super aligned because this will have to come off again. This all needs cleaning. I might crop it to length, I don't know. I mean, it's not doing any harm at that length there, but right, let's get this lined up. Drop that. There we go. Now, it's not going to be aligned this way, but as I say, it's just a quick dry fit up, and then it will come off to be cleaned. Alright, gives you a rough idea what it's going to look like. Just tighten that up so it doesn't slide down. It's gone out of frame, doesn't it? There we go. How about that? Yeah, it's in frame, okay. Right, gives you a rough idea what it's going to look like. I was thinking if I tap the centre of that, I might just put a bolt up and it will hold itself tight against the wood, and that, I've checked that that's square, this is pretty flat, and it might hold it, but I don't know, the wood might be a bit too soft and you know, move around too much, in which case I'll get these in Just means more holes and nuts and bits and pieces, but we'll see. And so the idea is we can adjust it till, so where would it be? Yeah, so the iron is as far down as it's going to go. In other words, the heat insert has gone to the full depth, so we get that, so let's say there, lock that off, and then we can lift this up. Soldering iron's hot, put the insert in, and then just let go, and the spring should press that down, and when it reaches that point we lift it up out of the way because it should be to the full depth. Alright. And I think I did it so when that was fully down, that should basically be at the bottom onto the board, which, yes, there it will be. Okay. Alright, looking good. So I think I'll take this off, cut it to size, tap both ends, because I've got an end cap to put on here, and in fact, do you know what, let's just go ahead and use these. These will be a lot nicer, and I'll definitely keep it square. I'm not sure I'll trust the wood to keep it square. Right, looking good so far, let's get on with that. And there it is, all put together and finished. Well, almost finished. The end cap here. So I printed two of these. I know it's going to be hard to show on camera. This one I printed that way down, and because, if you can see, there's like I put a radius on that corner. It's ended up with, they're like frilly edges just around that corner there. Can't really sand it or such, but yeah, that's what that's done. And then it's left, again, difficult to show on camera, a really nice finish inside, which is the bit you don't see. So I thought, okay, I'll have another go and print it with this side on the bed, and it obviously had to put infill material all around there, and you can see all that. I've just removed it, but then the outside, which is printed at the top, is much nicer. So yeah, a couple of options there. I think we'll try this one. So it's got a little cut out in the front, recess for an M8 cap head, and that should, and then a little cap head screw should fit in there. Okay, and there it is, looking pretty nice and almost complete. One last detail. Need to make that little lock screw down there. I did find this, which, so we're looking at about 41.6, so that was about 41.9, so that would turn down, but that looks like it might be stainless, which is a little harder to tap and so on. I mean, possible, but probably, again, a bit of a waste. That's probably about the only bit I've got. So had another rummage, and I've got quite a few of these off an old bit of kit from like yesteryear. So some kind of brass knob with, I don't know what that is, maybe a 6mm, could even be 1/4 inch, pretty old. So I thought I could sort of turn this, make it look a bit nicer, put an M8 screw through the middle there, and then drill and tap it with a set screw there, so, and Loctite it in. Just had a nice surprise. That studding I got was actually M10. I thought it looked a bit big. This is an M8 bolt, and that screws into there, so M8 is coarse. And so there's enough thread, I can chop that off, and then probably what I'll do, I'll put a grub screw down there with some Loctite around everything, jam it together, and that will basically hold that in tight, and that will be done. Then I'll just clean this up, and simple as that. Right, let's crop this to length, get the grub screw down. I think that'll be our first. I'll tell you what, we'll clean this up on the lathe first, then we'll get this set in place, and then we'll take it from there. So in case you're wondering, this is actually a curved surface like that. I've got no way of replicating that. I haven't got a trace attachment or anything like that. So I just did a tangent somewhere towards this outer 50%, sort of about there, and took that off. Obviously that ran out here, and then did a tangent down here, and then took it like that. So basically just two compound angles on the top of here. So the tool went in two different directions, first like that and then like that, just to get it in two passes. And then just sanded it in, it looks okay. Alright, so we'll set this up the other way around on a little mandrel, probably just an M8 bit of stud. We'll get the tailstock in, and then we'll just clean off this inner surface, and then we can get the thread inside. Okay, here's our part cleaned up. I think it looks alright. I know it'll tarnish eventually, but it'll look nice for now. Maybe we'll varnish it or something like that. Okay, anyway, let's put this thing together. So I've got my little bit of M8 stud, and then got a grub screw which will lock in. So I think we'll probably going that way. Just get a little bit on. Okay, and in we go. Okay, and as you can see, I've just taken the base off here. We'll come to that in a minute. While I was out and about today, I was in B&Q. It's like a kind of DIY store here in the UK, and they had these furniture sort of felt feet with nails in. So I just hammered those in 4 locations. Gives it a nice firm base to it, stop it sliding about. And so we just need to bolt it back on. Is it going going to fit? Is it long enough? I think so. Be careful not to over tighten it because you can really get a grip on this. Okay, all that's left to do now is try it out. I just hope the spring pressure is enough to press the insert in there once it's heated up. Okay, well, as you can see, I've just turned it around just so that you're able to see the display on here. Probably it's a bit more natural for me to do it the other way, but just so you can see on camera the temperature. So the first thing to do is we'll get our little insert in. I have been told these are the incorrect type. These are for plastic injection moulding, but they'll serve a purpose today. I'll have to get the proper things. I guess the ones I want, I've got like a lead-in collar, and also the kind of diagonal, almost like teeth rather than these. But you know, we'll see how we get on. Just a little bit of practice. Let's see what it's like to use. So again, these are not really the right type, so they're not going to work that well. And then oh no, before we do that, we've got to set the height, haven't we? So we'll just undo the collar and bring this down. I won't actually use this vise, it's just handy for now. It's not on the CNC machine at the moment because I'm machining some large plate material. Alright. So that is going to be full depth. So we'll lock it off there. Okay. Alright, and then this should be able to move up and down, yeah. So we'll bring this in, he says. Okay. Then we'll turn this on and heat it up. So see our little display, so I'll just do that again. Default is 200, 250. I've heard 300's a pretty good value, so we'll just give that a minute. What I might do is make up a little collar that holds that in place actually while you're waiting. Alright, let's give that a try. So I'll just lower it down and see if it works. It's going to knock that over, isn't it? And okay, looking alright. Let's let the heat and the spring pressure do it. It's going. And we can see how much we've got left to go on there. That's the idea of the test. Anyway, alright, nearly at the bottom, and we're there. Wow, I think it's gone slightly to one side, hasn't it? There we go. Yeah, it's alright. Alright. Well, I think there's a couple of minor things we can do. It can always be improved, can't it? But generally the principle works. Pretty happy with that. So I think this setup is great if you're doing multiples, because obviously you need to get that height correct. I think the spring could do with being a little bit stronger. I'll have a look online, see if I can get something a little bit thicker. Because it went in very slowly, didn't it? And a bit worried that could just sort of ooze itself off to one side or something. Some other thoughts are, obviously I've brought it out here so you can do big parts. Maybe I could print another one of these with this clip kind of halfway along the sticking out the side like that, so it's kind of here, so you can have, you know, small parts the other way around, whatever. I have seen some of these heads actually slide along a rail like that, you see, but I thought I'd keep this as rigid as possible, keep it nice and square. That's a possible, but yeah, maybe, you know, it works, does work. The other thing was probably just get a little collar just to go under there. Be nice if it was sort of part of this, or maybe a locking screw under there, so when you lift it up you can sort of click it in place, heat it up, put your insert in. When you're ready to go, you push something and down it goes. Yeah, I'll have a think about that. And also a little cable guide up here would probably be good, although having said that, I've got the cable going off that way now because I've turned it around, so maybe I'll leave that. Anyway, as you can tell, I always like fiddling with things and I can never leave it be. I think I'll tell you what we're going to do. We're just going to leave it. We'll use it, see what we like, what we don't like over multiple inserts, and if we really need to change it then we will, but maybe it's okay. Yeah, it's good enough. All right. Okay, so there we have it. Inspired by all sorts of things I've seen on the internet, sort of what I thought was the best features of all the devices out there, particularly Naomi Wu's, which I'll put a link to down below so you can go and check hers out. Yeah, it seems to work on the sample of one. I know these are the wrong inserts, but I think the principle is there, isn't it? And I'll use it for a bit and see how we get on and see if I need to make any changes. But yeah, otherwise, very pleased. Okay, before we go, two things. Firstly, I'm not planning to turn this into a 3D printer channel. Obviously, this is a very useful tool to have around the workshop for making brackets, clips, and all sorts of things that would be difficult to make in any other way. Certainly, the speed that you can print these things out and iterate as well. You can print a few variations out pretty quickly. Actually, that's one of the downsides. If you like fiddling like I do, you can print it out and go, I could make a change there, and you never stop. You've got lots of iterations of some of these designs. So yeah, that's the first thing. And secondly, I hope you've enjoyed watching this. Normal business will be resumed. We'll go back to engineering and machining, and I'll get back onto the drill press project, which hopefully will finish soon. And with that said, thank you very much for watching, and see you next time.